Hi, I'm Paul Hudak. I'm a business analytics consultant with LPA Systems. Today we're going to talk about text analytics. In this presentation, it's adapted to give you an introduction to what is text analytics. So we're going to talk about some different things when it comes to text. I want to give you an introduction to text mining and text analytics. You'll hear both of those terms kind of used kind of synonymously. Text analytics use cases will be the next thing that I'm going to go through. I've chosen a couple areas to talk about applications for this technology that I think you'll find interesting. Then we'll jump into the development process on a text analytics project. And then I have a demo planned. We'll go through a stream. I'll show you how the SPSS Modeler tool runs through the extraction, the linguistics process that extracts meaning out of textual data and allows us to use that data in reporting in a predictive manner. In a lot of different ways the data can be used. And then the summary of we'll wrap things up with the summary. So the first section here is an introduction to text analytics. And the question is, what is text analytics? Well, Wikipedia defines text analytics as the process of extracting knowledge and information from natural text. Now, extracting knowledge and information from natural text is definitely something that we use text analytics for, although there is more to it. We can also extract meaning and insights from non-human language text, so things like server logs or possibly network type of logging, things of that sort. So there's really two fundamental actions when it comes to text analytics, and I've kind of simplified things. I have these two steps: the extract key concept and terms step, and that's the process where we're allowing, in this case, SPSS Modeler text analytics to read in the textual data and extract concepts, things that are prevalent inside of the text. So these are things that they're not necessarily terms, but they're kind of they're higher level meaning of terms. So you'll have different groupings of terms that roll up to a concept. After the extraction takes place with text analytics, we move to it's almost like an association phase where we're grouping these concepts into higher level meanings. And in SPSS, we call that categorization. So we're taking these concepts and sometimes we may apply sentiment. So we may look for positive or negative sentiment applied to a certain concept, and that will allow us to find out different things about the data. If people were favorable or unfavorable about the concept we're looking for. So that can be very useful with text analytics. From there, from a fundamental action standpoint, any subsequent steps will be dependent on if you're doing analysis or using the extracted results in a predictive model, and you would basically follow the same path, follow the path depending on what the desired outcome was. So where does text analytics fall in the analytics maturity, this analytics maturity chart? So we know what reporting is, reporting on what has happened, and we have the analytical and monitoring phase, using the reports to arrive at assumptions on why we think things happened. Predictive analytics is another area in the analytics maturity where we're using data to make projections on things that are likely to happen, and then prescriptive analytics being a natural extension of predictive analytics, what to do given the alternatives. Now, text analytics, I'll argue, can fit into any one of these areas. Text analytics, after the extraction has taken place, we now have concepts and potentially categories that we can use in reporting. So we can look at a customer survey, for instance, and extract concepts. We can take those concepts and then run that through another reporting tool, so say Cognos BI, and allow reporting on the contents of what was being said in the comments section of, say, a survey. SPSS Modeler is a very nice tool in that it will allow you to run the extraction and then port those results over to your Cognos BI installation, making reporting fairly quick and easy. analysis and monitoring, we can take those results out of text extraction, and we can analyze those results. So we can look for trends. We can look for sentiment is a very useful analysis tool, determining if people were negative or positive about a topic that we're interested in. So we can use text analytics for analysis. Predictive analytics is something that's very natural for text analytics. So after we've created our text extraction, we've taken that unstructured data and we've created structured data out of it. Now we have categories. Depending on how our predictive model is set up, we may have those categories or concepts built into our predictive model and as new columns to our predictive data stream. So in effect, now we have instead of having text, we now have in effect ones and zeros or flag fields that we can use in our predictive models. And then prescriptive analytics. It's a natural extension of predictive analytics. So we can take the text analytics output through a predictive analytics project and use that in our prescriptive process afterwards. So where is text analytics used today? Well, I challenge you to try to find an industry or a company where text analytics couldn't be used. Customer insight analysis is something that I have a fair amount of experience with, and that's using natural language text, so specifically survey data, and gaining insight from what has been said by customers, and using that to basically make decisions or provide data to make decisions. Predictive analytics is another thing that text analytics can very easily be used from. So now that we've extracted the concepts or categories from our text, we now have ones and zeros. I've already mentioned this in the last slide. So we can use those ones and zeros in our predictive models. And I read something recently where something like 80% of the data available isn't used in predictive models because it's in unstructured format. So this is another way to, if you have a predictive model that maybe you're facing not enough data to get an accurate prediction, or frankly you just don't have enough data. This may be another tool in your back pocket you can use to gain more data to feed into your predictive models. Threat and fraud analytics are another interesting and very useful application for text analytics. So I was involved with a company that used text analytics to try to identify insurance fraud. This was used with basically through an extraction process of the concepts and categories we were interested in. We were able to roll that up and produce a kind of like a fraud profile out of it, and allow for more easily identification of a subset of claims that could be inspected for fraud. Text analytics can be used across really all industries. It can definitely drive tangible return on investment, and can really get to every point of your contact in your business cycle. So from the most granular level, the transaction level, you can gain insights using text analytics, but you can also roll that up to a higher level, summary level, and possibly aggregate those results to find more meaning further down in your business process. So now that I talked to you a little bit about what is text analytics and where it can be used, I want to jump into some use cases. And the first use case that I want to talk about is a fraud detection use case. What we're looking at, you'll see in the upper right-hand corner, you'll see and those are categories that are created. You can see that each category has a human legible name, and we have concepts that roll up to those. Now that chart is showing the relationships between each category. So the thicker the line between the dots indicates a defined relationship between those categories. So that can be very useful for an analyst in fraud detection. So as you're going through the extraction process, you can basically use text analytics to look for terms or aspects of your business or things that people are mentioning in their in their textual content. You can use text analytics to mine for those interested concepts and categories, and then use SPSS Modeler to do assessment of the relationships between these things. In the demo, I'll show you a little bit more about this, but I think it'll be a little more evident when I can actually work through the model. But you'll be able to see how we can actually take something that somebody is saying and then use analytical capabilities of SPSS Modeler to systematically define what people are saying. So I mentioned earlier something like 80% of data is in unstructured format, which means that most prediction models are not using all of the available data. Text analytics can definitely increase accuracy of fraud detection models by using, and this depends on the data sets, but using the data that's available that might be in unstructured format and transforming that into structured data, and then allowing for further deeper data sets for fraud detection models. We can reduce overhead reusing these tactics. So enhancing our fraud detection models with text analytics can do a lot of things. We can present to the fraud group a much smaller subset of instances or cases where fraud is suspected to have happened. So what that does is it reduces the overhead for time that the fraud team takes to investigate fraudulent claims or fraudulent transactions. Obviously, the reduction of fraud is a definite benefit when it comes to fraud detection. Reducing fraud is going to save an institution money. The next application that I wanted to talk about was for marketing. Now, this can be very interesting, a very interesting use case, because there's a ton of applications for marketing. So you can use not just text analytics, but predictive modeling to try to determine which customers are likely to respond to your marketing campaigns. Well, with text analytics, we kind of have another tool in our back pocket where, say we have a model that is trying to identify those users that are most likely to reply to our campaigns. We can mine different data sets now. So now we have, for instance, social media sites, Twitter, Facebook, things of that sort. Those are fair game now. So we can use text analytics to look for customers that are mentioning specific things about our company or mentioning our company. Use that data for a lot of different things. We can use that to drive, like I said, predictive models, seed more data into predictive models. But we can also use that for analytical purposes. So now that we have the ability to mine social media, we can identify influencers, and we can identify trends and the social media sites surrounding specific subjects that we maybe didn't have access to before. So we can go and we can mine Twitter and see what people are saying about our company, if they're positive, if they're negative. This will absolutely give us better insight into what our customers are truly saying. Can have the benefit of maximizing our customer lifetime value. So if we find things that are problematic with our business, we can address those more readily. This will increase our long-term customer profitability. It can also assist with customer retention, so churn modeling. One other thing I didn't mention: if we have a campaign that we're running and we're curious about possibly penetration, we could potentially use the social media as a data source to assess whether certain campaigns are having an effect or defining the reach of a campaign. Using text analytics would allow for that with social media, to see what's being said outside of our company walls. So the next use case that I wanted to bring up is something called voice of the customer. In this use case, it is similar to marketing, although it's more focused on the actual customer. So the definition of voice of the customer is an in-depth process of capturing a customer's expectation, preferences, and aversions. So this is a great application if you're interested in tracking customer sentiment. And you can see that using social media would absolutely do that. But a lot of times, a lot of companies, they have textual data inside their company walls. So for instance, from the survey standpoint, we can tell a lot of things about how our customers are perceiving either our company or things about our company. We can assess that. Text analytics is a very useful tool, to allow for that. Social media I mentioned is another way, another data set that would be useful for voice of the customer assessment. And then really any other outward-facing data sources that we might have. If it's hard to say what other outward-facing data sources a company might have, but if you have something that is is available to you, that is in a textual format, using text analytics to structure that data would definitely be a benefit, especially to an analyst that is working to understand the voice of their customers. So this is going to allow us to understand key customer concepts over time, so we can look at things. So we might have a concept about ease of use for a certain product. Well, we can assess the customer's kind of their feeling on that, and we can actually track that over time. So after initially we noticed that so for instance, we might notice that there's a problem with ease of use with one of our products, and we can track the mention of those terms over time, and we can see that if there's an increase or a decrease over time, there may be a problem. In the use case that I'm going to go through the demo, there's something that was uncovered relating to instructions that I'll get to that can actually show that. We could actually track that over time. So we can also use the concepts and categories that we run through extractions to create segmented customer groups and clusters. So in the lower right-hand corner, you'll see a pie chart. And cluster 1, which is the light blue slice of the pie, this customer group lives the closest and has the highest positive sentiment out of all the customer groups. We also note that it is the youngest demographic. If we look at cluster 3, this is what we call an at-risk of churn cluster. This cluster has the most mentions of pricing concerns in their survey comments, and they also have the most negative sentiment score. So this is useful for an analyst to take a look at that segment and further define what is going on with that subset of customers. We can also use text analytics to define, from a voice of the customer standpoint, what external influences are having on the behavior of our customers. So is a negative thing in the press, a negative mention of something in the press, having an effect on our customer retention or maybe our net new customers coming into us. This is something that we can use text analytics for, and it can be very useful to find things that weren't possible in the past. So now that I talked about some use cases, we talked about 3 different use cases. I hope you found those interesting. The next thing I want to talk about is the development process that we go through with respect to a text analytics and text mining project. So the platform that we use for text analytics and text mining is the SPSS Modeler product. Modeler is a great tool. It allows for data inspection, data discovery. It's a platform used for predictive analytics as well. So we use SPSS to create predictive models. Well, one of the components of SPSS Modeler is the text analytics package. Text analytics package within SPSS allows for the extraction that I've been talking about. So it allows us to go in and read in a textual document and then do things with that. So it allows us to run extractions. If we want to run very basic concept extraction, we can do that. We can also create higher level meaning with the tool as well. We can then take that data and feed that into our data streams, our predictive modeling streams within SPSS Modeler for use inside of a predictive model. So the methodology that we use in text analytics, in predictive analytics, is the CRISP-DM methodology. And what CRISP-DM is a framework that we use to basically start a project, and it allows us through iterations to get through a project and to have reproducible results, project after project. I'm going to go a little bit through the CRISP-DM methodology. You can see In the graphic on the left, there's business understanding. So this is the section of CRISP DM that the modeler would gain understanding about the business. So it would find out what the problem that we're trying to resolve is, and then understand just different aspects about the business. The data understanding phase is the phase where we're taking the problems that we've learned from the previous phase and trying to map those to data that's either available, data that we need, and basically identifying different data sources that can be used for our ultimate goal. Data preparation in a normal predictive model, this is where a lot of time can be spent. I've seen at some points where it can be 70 to 80% of your time can be spent on the data preparation. With text analytics, depending on what your ultimate outcome is, if it's a predictive model or if it's for analytical purposes, you may spend even more time here. One of the steps with predictive analytics with text analytics that you may not have in a purely predictive model that's not using text analytics is the association of an extraction process of extracting concepts and then creating higher level categories, higher level meaning, assigning sentiment. That all kind of falls into the data preparation phase. We follow that up with modeling, and that is the process of evaluating our models, looking at our models and choosing a model, and the evaluation actually takes place after modeling, where we're evaluating our results, maybe finding out things that we didn't know in the previous phases and taking a step back if necessary to either refine our data preparation or maybe augmenting our earlier stages. The deployment phase is where we're taking our results and we're making them available for who our target audience is. If it's an analyst, so possibly running extractions through SPSS Modeler through text analytics and moving those. It could be as simple as moving those results to Cognos BI for an analyst to report on. It could also be as complicated as creating structured data to feed in that would ultimately be feed into either an existing predictive model or as a part of a new predictive model too. On the right, I've also listed some roles that a company can look at as kind of a framework for who wears what hat when it comes to a data mining project or for specifically for text analytics type of project. So now that I've talked to you about text analytics, we've got a little bit of insight on what it is. And I've given you a couple use cases, and we've talked a little bit about the development life cycle. I'd like to move into the demonstration portion of this presentation. In the demonstration portion, I'll give you some background on the company that we're gonna look at. So we're gonna use text analytics to solve a business problem. In the business problem, we have a company that is a provider of touchscreen devices with touchscreens, and this company has noticed that they're losing certain portions of their customers for a competitor. So what we want to try to do is, from a recent survey, we would like to try to leverage the comments from this recent survey and try to gain some insights on why this might be happening. We want to identify some key concepts, key things that people are saying, or key concepts of what people are mentioning inside of their surveys. And then we also want to try to figure out what we can do to retain more of these customers. It costs something like 5 times more to gain a new customer versus retaining an existing customer. So this is a very valuable application of text analytics in the real world. So I'm going to move off to SPSS Modeler. And I'm going to show you a stream here. So what you're looking at is SPSS Modeler. And you can see that there's some symbols here. And I'm not going to go through every symbol, but I'll try to give you a quick overview of what some of these are. So these round symbols, this is a source node, and it allows us to connect to different data sets or data sources. So you can see here that I'm just using a simple Excel file. I can also choose my source node down here. I can change my source node to different different type of data source. So I have source nodes for SQL database, variable files, fixed files, and all kinds of different data sources I can use. If I go into the source node, simply, it's very simple. I basically point the node to my data set, which is right here, this touchscreen survey v2, and I can preview this data, and I can show you what it looks like. So here's what our underlying data source looks like. So we have a respondent ID. This is just a unique identifier for each survey. We can see the verbatim here. So we have comments about using touchscreen devices, and we can see what the customer said. Then I have three other columns. I have the age group column, which shows me the age group of the customer that provided us the comment. I can see how many vehicles they have in their household, and also their marriage status. Now I'm not using these last two columns since I'm doing more of a more analysis right now. I'm more curious about some of the content that people are talking about. If I was to use a predictive model, I would probably use these as inputs in my predictive model. So that's what the survey looks like, and this is the source node inside of SPSS Modeler. I then have a type node, and what a type node does is tell SPSS what type of data we're using. So I can flag a field and say it's a field that is providing measures, the type of different categories. It's a categorical field. It's basically a way to tell the model how a variable or a column will be used from your data source. I then have the text analytics node, which is the main reason for this presentation today. And if I go into this text analytics node, I can see that there's some different fields here. There's a couple different tabs. This first tab is the Fields tab, and this shows you this gives you the option to point the node to your comments. So you can see here I have Q1 comments about using touchscreen devices. That is the title of the field where our comments are located. And I have a few other options here too, depending on what type of data source you have. On the Models tab, this is the section of the node that allows me to define the type of interaction or the type of extraction I would like to run against my data set. So in this case, if I was to run the resource template extraction, I'll show you what the options are here, and I click on load. I have some different options here. So there's all kinds of templates. You can think of them as like library resources. So if I have, in our case that I'm going to talk about here, we're talking about a customer survey. So it might be useful to come down here and use the customer satisfaction opinions, because people are, it's a customer survey, and they're going to be expressing opinions about either a product or a service, things of that sort. If the data set was different, for instance, let's say I had an employee survey, I have another resource template here or library that I can use, we call it employee satisfaction opinions, that would be more tailored to that type of subject matter. Well, I'm actually not going to use that resource template. I'm going to hop over here to my text analytics package. In my text analytics package, I have some higher level meanings that are built into the package. So I want to do a sentiment analysis. I want to try to figure out what customers are saying in relation to different aspects about my product. So if I click load here, you can see that I still have some similar, these should look fairly similar as compared to the other, the resource template. These are a little more complex. So this is going to have, it's going to have some more, it's going to have some more logic inside that's going to allow for some deeper analysis. So you can see here when I click on customer satisfaction, down here at the bottom, I can tell it if my survey is mostly mixed opinions, positive opinions, or negative. And this is very specific to the type of question that's being asked and specific for a survey. So the question we asked is open-ended. Tell us about your touchscreen devices. So I may have a survey that says something along the lines of, tell me about some of the bad things about things you didn't like about our product. In that case, this would be a negative opinion survey, and the extraction results would be more weighted towards the negative opinions. So it's just something to be aware of when you're running through your text analytics extraction process. So I'm going to go ahead and run this. After I've made my selection, I've chosen text analytic package. I'm going to go down here and click run. So when I click run, SPSS SPSS then allows the text analytics language processing engine to read in the textual data that we're interested in and makes an initial extraction at the concept level, and will also do some initial sentiment assignment too. So when I come over to my text analytics, my extraction results, I'm going to clear out the defaults here. I can see that I have a lot of concepts here. So it's picked up on a couple different things that we would expect. So we can see that there's a lot of mentions of touch, and there's a lot of mentions of touchscreens in our data. Well, knowing that our data set is based on touchscreen devices, we would expect that that would have a high number of mentions. If I move down a little bit, I can start to see some interesting concepts here, and I can see that there's some mentions of cool, and that's kind of interesting. I'm going to hit display so we can read some of the verbatim comments. So within this extraction tool, we can look at the concept, and I click on it, and I can click on display. And what that does is it allows me to come in and see the actual verbatims that are tied to this cool concept. And we can see things like touch is cool, sliding, pinching, sweeping over the screen is cool. And these are things that the comment that they have made in their survey. On the right, we see the category assignment that SPSS made. POS indicates that this was a positive comment about features design. Now, one thing to keep in mind about the extraction results is, and this is the part where you'll have some time in kind of training your text analytics about your business, or about what people are saying about your business. So cool in context of our survey is a good thing. It may not be in another sense. So let's say the survey was a survey on soup quality at our restaurant, or at a restaurant. Well, cool soup in most cases is probably not a good thing. If the soup was cool, that may be negative. So we may want to reassociate our cool concept right here. We may want to reassociate that to a negative type of meaning, and we have the ability to do that within the tool. We can come to our assignment here. You can see there's this type column. What a type is a higher level of association of concepts. So you can have multiple concepts that roll up to a type. So you can see there's, this is a good example here. We have cool, easy to use, and excellent. And they all roll up to the same type, the positive type. So we may want to change cool from the positive type to the negative type. And it's just as simple as right-clicking, add to type, and coming up and choosing negative with 1 and 2. Consequently, we could actually come over to our resource editor and make the same change. So we can come in and come into our opinions library, and cool was a positive term. We can locate cool. Let's see if I can find it here. There's a lot of terms here, so it's hard to read through. But let's just choose the subject matter. I guess the term itself isn't important. It's basically what I wanted to show you is that it's easy. Let's just choose something like correct. We can change that term. We can change that over to negative at that point if we wanted to. If we were to drop it there, so that would actually move the term that's rolling up to that type of to a new type of type, a new type. If we wanted to reassociate those types of what people are saying. Let me switch back to the categories and concepts area. And one thing I'm looking at on the upper left-hand corner up here, I'm going to run a score. And I can see that I have these categories here at the top, and I have NEG, POS, CONT. So what SPSS does out of the box, I chose a text analytics package that had positive, negative sentiment applied to the categories. So SPSS It's very good at this was out of the box. I didn't run any kind of I did very I'll say I did very little kind of massaging of the roll up of the categories on here. So we can see things like, let me just go through here. Negative quality reliability is the one I wanted to look at. And if I click display, what I can do is I can see some of the verbatim comments that people are saying that roll up to this type of category. So typing is difficult on touch screen. So that's somebody mentioning that there's some usability concerns, and we can see that its sentiment is negative for the most part. This will be something that, as part of a text analytics project, part of the project is going through and trying to evaluate the extraction process and the categorization process. Are we capturing number one, are we capturing the concepts correctly? Are we capturing is the sentiment being applied in an appropriate manner? This is all part of a text analytics project, and it sometimes can be a large portion of your time spent on the project. So from an analytical standpoint, I'm going to click on the category web, which is a tab up here. I have a couple different tabs. The category web, I've chosen quality reliability, and I can see here that the size of the circle indicates the number of documents that contain that category. So I have roughly like 40 documents, actually 39 documents, if I mouse over it, 39 documents that are negative quality reliability category have been assigned to that comment. And I showed you earlier in one of the slides the relationship definition between the relationship is we can assess that by the thickness of the line. So I can see, for instance, over here that we have a category called negative instructions, and I can see that there's a very strong relationship between the two. So going through the results, I can find out that customers that are having quality reliability concerns are also very negative about instructions with the product. So that might, as an analyst, that might be something that I want to look into. Are our instructions clear enough? Is there some inaccuracies inside of our instructions with the device? As an analyst, I can come in and use this as a tool as well. So this is a very it's a higher level overview of of the text analytics workbench. Normally, what I would do in a text analytics project is I would work through numerous extractions, possibly create new categories. So there may be categories out there that the software, that SPSS Modeler text analytics is not picking up on. I may want to add those manually. So to do that, it's as simple as creating a new category in this upper right-hand corner, and then associating your lower level concepts to that category. The workbench allows for a very easy path to create new categories. So there may be, there may be something in the text, like I mentioned, that isn't being picked up on either properly or just not being picked up on at all. I can build that manually. And that part of a text analytics project can be a large portion of the project, depending on your outcome. So after I've ran my extractions and I'm happy with my categorization, I'm then ready to structure this data. And to do that, I simply, actually I backed out too early here. When I'm ready to do that, I click this button here. And this is the generate model button. What this will do is it will create it will run all of my categories against my data coming in and create columns. And actually, I'll show you this here over in the stream. If I go back to the stream, we can see I have two nuggets here. This is the output from a text analytics workbench session. If I go into the nugget, I can see I have all of my categories here. So you can see I have negative discomfort, negative feature design, so on and so forth. Positive comments are also included here as well. If I click on my comment or my category, I can see the descriptors and the rules that are driving that category. And this corresponds directly to that category view that we were looking at in the upper right-hand corner in the last, when I came out of the workbench. So for our purposes here, I would like to, I'm going to say, create the categories as fields. So for each category, I can expect to have a field for each category. So for features, negative feature design, I'll have a new field created or variable. We can call it a field or a variable. I'm using that kind of synonymously. I have that new field created inside of my data source. So let's see if I can show you what it looks like. I'll click preview. What that's doing is it's extracting the results, applying my categorization to the comments, and then taking those results and creating new fields. So you can see here, for instance, category context feature design, it's a flag field. If the category was present inside of the comment or inside of the text document, it gets incremented by 1. Actually, not incremented, it gets set to 1. If it's not present, it's set to 0. So that can be very useful for especially a predictive model. You can see that I had roughly maybe 30 categories. Each category is now corresponds to a column in my data source. Sorry, not my data source, my stream data. So if the ultimate goal was to create a predictive model, I now have more data for my predictive model. And you can see here that each one of these columns, some have 1s, most have 0s, which is what we expect. We wouldn't expect to see mostly 1s here because we would, especially with a number of categories in the 30 to 40 range, you're going to have much more 0s than 1s. So it is what we expect. So I created the categories as fields, and inside of our stream here, I'm going to create a couple new fields too, because what I ultimately want to do is I would like to assess the sentiment. And to look at overall sentiment, I am going to sum up. I'm basically creating a new field that's going to add the 1s from the positive categories. I have another one to assess, basically add up all of the negative categories as well. So if the category was negative, I'm summing up all of those fields to arrive at a value. And then I'm doing some comparison with this node. I call it the overall sentiment node. I'm basically comparing positive and negative. So if the comment only had positive mentions inside of it, then it's a positive comment. If it only had negative, sentiment, then it's a negative comment. If it had both positive and negative, I'm calling that neutral. So we can't really make an assessment on whether the whole comment was positive or negative. So here's what the output of this looks like. What this is here is a distribution node. And you can see here that I'm looking at the age group, and I want to assess the overall sentiment. I want to look at the overall sentiment field. This setting corresponds to our new field here, this overall sentiment field. I'm going to run that. So what we're looking at is a distribution of the overall sentiment for our population. And we can see some different things here. We can see that there's some interesting things here with respect to age group. We can see that the older demographic, the 60+ population inside of our survey, those people are less positive, so they have less positive comments. Consequently, they have more negative comments too, which is also very useful. Our most positive demographic is the 40 to 49-year-olds. They seem to have the most positive comments and also the least amount of negative comments. So that's useful. That's useful to know. So now we've made an assessment of sentiment with in relation to our survey. But I want to take that a step further. I want to drill that down to not just the sentiment level. I want to take it down to the category level. So I want to find out what they were negative about or what they were positive about. So I showed you this survey with comments nugget here. I basically made a copy of that output, and placed it up here. And I'm going to look at the data in a different way, and I'll show you how I'm going to do that. If I go into it, the initial modeling tab is exactly the same. And if I go to the settings tab, this is where the difference is. So in the previous node, I had categories as fields. And to the right, you have this other option, create the categories as records. So instead of creating ones and zeros, instead of creating new columns, 30 new columns, and creating ones and zeros for each column to denote whether the category was present inside of the comment, I'm going to create one new field. And this new field is going to contain the category name. Now the category names, if you remember, contain the context of what the person was talking about. So features, design, but it also contained the positive and negative sentiment on that category. So this is going to be useful. It's going to allow me to kind of look at the data in a different way. So I'm going to hit OK. And I'm looking at since I'm only interested in what's driving the negative behavior of a user group, I'm just going to pull out the negative, or we're going to focus in on the negative comments. So that's what this node is doing. It's basically just selecting the instances where there was a negative comment so we can look at the distribution of that. I'm going to come down and I'm going to click Run. This is the same node as before that's going to show us a distribution of our data in a graphical format. So now I'm able to come in and I'm able to see a few different things. I can look at my my negative group, and they are not heads and shoulders above the others, but it does seem to be that the older user groups are having some negative, much more negative comments about our products than not, or than the younger user group, the younger age groups. Specifically, I can see that pricing and billing is a major concern here for the 60-year-old plus age group. Another thing that wasn't apparent before was in this younger group, we have a fair amount of negative comments about the speed of our touch screen product, and that might be something that we want to take a look at. So now we've gained some new insight into what might be driving some customers to leave. So I'm going to switch back to our slide deck. And I'm going to go over our results from our text mining. So we're able to figure out that customers that had the most negative sentiment were in the older age group. So we saw that the 60-plus age group seemed to have the most negative sentiments, the most negative comments in their responses on their survey. We identified some drivers for the negative comments with respect to the age group. So we saw that price was a very important mention, or very had a high number of mentions, pricing and billing, for the age group. So the older group appeared to be more price sensitive than the other. We're also able to tell that the younger customers appear to be more dissatisfied with the speed of their product. Well, what can be done? What can be done about those things? Well, we have a couple options to us. We can improve the retention by offering discounts to our customers on fixed income. So possibly in the 60-plus age group, a fair amount of those customers maybe are on fixed income. And through analysis, we've identified that there's a lot of customers that are on a fixed income. So offering discounts and things related to pricing, more favorable pricing for that age group, will allow us to keep more of those customers. We can create some targeted offers to other customer segments as well. So we noticed that speed being an issue to the younger age group is also it's something that's mentioned as being negative inside of their comments. So what we'd like to do with that is we'd like to upgrade anybody inside of that age group, when they re-sign a contract for our our devices that contain our touchscreens, and upgrade them to a later type of device that will have better speed. Consequently, we can also take this insight, this speed insight, back to our R&D or our development teams, and use that in our development process for touchscreen performance. So allowing for faster tapping and quicker response times in our touchscreens. We can also begin to track these concepts or these categories over time, and we can measure our progress. So now that we know that speed is a major concern for the younger age group, we can use a line chart against our extraction results to see the number of mentions of speed in customer surveys over time. So we can see how our initiatives are working to reduce the negative sentiment, the negative responses by customers. So in conclusion, we've learned a lot today. We've talked about quite a bit in relation to text analytics. We've talked about what it is. We've talked about some use cases. We went through the development cycle. We just went through a demonstration of how the tool could be used from an analytical standpoint. Keep in mind that there's something like 80% of today's data is unstructured, so that's fair game for a text analytics project like IBM SPSS Modeler. In business, we're always trying to find new ways and new methods to obtain a competitive advantage, and this type of tool is could very well be a very good competitive advantage for an organization compared to companies that are not using this technology. You can contact LPA for further information on setting text analytics, and you can contact LPA for further information on text analytics and to set up an initial consultation to assess the effectiveness of text analytics in your business.